Continuing on in section 1.1, we can use words or an algebraic expression to write a mathematical rule that describes a real-life problem. So in example 5, we're going to write a rule to describe a pattern, and this pattern deals with the picture on the top of page 6. The table on page 6 shows how the height above the floor of a house of cards depends on the number of levels. So what's the rule for the height? Give the rule in words and as an algebraic expression. So if we look here, there's a table, and then on the table is where the house of cards is built. Each card is 3.5 inches tall, and the table is 24 inches tall. So to figure out the rule for the height, we're going to take the height of a card times how many rows there are, or levels. And then don't forget that we have to add on the height of the table, because we want to know what is the height from the floor, height above the floor. Okay, so in the first one, for 2 levels, we have 3.5 inch card and 3.5 inch card plus the table. For the third one, we have 3 cards, and each card is 3.5 inches plus the table. For the fourth level, we have 4 cards, and each one of them is 3.5, and we represent that repeated addition with multiplication. And then don't forget that we have to add on that table. So if, let's say, we had n number of tables, we don't know, okay, random number, okay, we're going to use our variable n, and I'm going to plug that in for my row here, because if we can see this pattern, 2, 3, 4, and 2, 3, 4 is the same, but everything else didn't change. So the 3.5 is constant, multiplication is constant, and n is our number of levels. We're going to take that, and don't forget that we still have to add on that table. So that's our algebraic expression. It's algebraic because it has that variable in it. These first 3 were numeric because they didn't have any variables, but the last one's algebraic because it has a variable. So anytime it says something about an algebraic expression, know you're going to have a variable. We want to write it in words as well. So here we could say we take the card height of 3.5 times n number of levels, or number n levels, and then add on the table, that's 24. Or we could say the product of 3.5 and the number n and 24, or plus 24. We could say the sum, lots of different ways there. And we talked about those on the last one, so I'm not going to write it out. But make sure that you do the rule as words and an algebraic expression there. A group of students built another house of cards that had 10 levels. Each card was 4 inches tall, and the height from the floor to the top of the house of cards was 70 inches. How tall would the house of cards be if they built an 11th level? So we've got a lot of information here. Let's pick out what's important. A group of students built another house of cards that had 10 levels. So 10 levels is kind of important. Each card was 4 inches tall, and the height from the floor to the top of the house was 70 inches. So from the floor, then we have a table, then we have a house of cards. This whole thing is 70 inches. How tall would the house of cards be if they built an 11th level? So we want to know if we added one more stack of cards here. Well, the only thing that's changing is we're adding that 11th level. So we're still going to have this original 70 inches, but we're also going to add in one more level. And each level is 1 card tall. So here, 4 inches tall, which means our new height is going to be 74 inches. We also could do inches like this, or write out inches. 2 ticks means inches, 1 tick means foot. Another group of students built a third house of cards with n levels. So here we don't know how many levels. Could vary. Each card was 5 inches tall, and the height from the floor to the top of the house of the cards was 34 plus 5n inches. How tall would the house of cards be if the group added one more level of cards? So here, our height right now is 34 plus 5n inches. And it says we want to add one more level. So we're going to add on And each level, each card, is 5 inches tall. So we're going to add 5 there. So we can leave it like this if we want, or we can take 34 and add the 5 and get 39 inches plus 5 in. And we'll talk about that a little bit more next section. But for now, 34 plus 5n plus 5 would have worked as well. And there again, all we were doing was adding one more level of cards. So we take how tall the card is, and we add it to the height we already have. Quick recap here. Algebra uses symbols to represent quantities that are unknown or that vary. Mathematical phrases and real-world relationships can be represented using symbols and operations. And that's all I have for section 1.1.